Hello everyone. So we're going to do a pre-lesson on 8-1 before you actually get into taking your notes from your online textbook for 8-1. Make sure that you copy down the examples when you are taking notes in the book. For now, you don't need to take any notes. Just listen, follow along as I read through the notes and give some more comments. So as an overview, this is the first lesson to factoring polynomials. You can think of factoring polynomials as the opposite of multiplying polynomials. So you're like undoing the distributive property. Here's a visual. So I have an example here with that blue arrow, double-sided arrow in the middle. On the left, you have a not factored form of the polynomial, 6x plus 8. That's just a linear binomial. And then on the right-hand side, the factored version will look like 2 parentheses 3x plus 4, or 2 times the quantity 3x plus 4. Notice that on the right-hand side, if you did multiply it out using the distributive property, it would be 2 times 3x, which is 6x, plus 2 times 4, which is 8. So those two polynomials are the same thing, the one on the left and the one on the right. The right-hand side is the factored form. So that's what we're going for. And you might be wondering, why do we care about this? You will be needing this as far as simplifying expressions going forward. Recall that a monomial is a single term in a polynomial with a number and a variable with a positive exponent, or just a number, and that would be a constant. So you've got like 6 or 5, that's just a constant. So this lesson is all about finding greatest common factors of monomials, and then we'll move on from there for the next chapters. So in the past, you found greatest common factors of numbers. For example, and remember we call it the GCF. The GCF of 4 and 6 is 2. So 2 is the greatest number that goes into 4 and also goes into 6, the greatest factor. And then another example, the greatest common factor of 12 and 30 is 6. Okay, so moving on, what happens if we have variables? So I'm going to do 2 quick examples and hopefully it makes sense. It's not hard because we can separate the number part and the variable part. So example 1, what is the GCF of 2x and 4x to the 4th? So again, your hint is to think about the number part and the variable part separately. So for the solution, we first look at the number part. The GCF of 2 and 4 is 2. The greatest number that goes into 2 and 4 is 2. Then for the variable part, this is something new and it's very important, but it's very easy. The GCF of 2 variable terms is the variable that is raised to the lowest exponent of the 2 terms. For example, when we have x and x to the 4th, x is your GCF because remember, x has an invisible 1 as an exponent and 1 is less than 4. So it is that easy. When you're looking at variables that are the same, so they have to be the same variable, raised to a power, in order to find the greatest common factor of the two, you find the one with the lower number, the lower exponent. So the GCF of x and x to the 4th is x, and then we put the two things together, the number part and the variable part. The GCF of 2x and 4x to the 4th is 2x. For example 2, what is the GCF of 28x to the 5th and 21x to the 8th? So the number part, 28 and 21, the GCF of that is 7. And the GCF of x to the 5th and x to the 8th is x to the 5th because 5 is less than 8, remember that? And x is the same in both of those cases. So the GCF of 28x to the 5th and 21x to the 8th is 7x to the 5th. Okay, so this finding the greatest common factor for monomials is just the first step in factoring. So you aren't actually factoring in these two examples, you're just finding out what to pull out of the parentheses when you are going to write out the factored form. So keep that in mind. You will have some examples of how to use the greatest common factor to factor out the monomial. Okay, so go ahead and take your notes on 8-1. Make sure you highlight the terms, write down all the examples. Please email me if you have any questions at all. Okay, enjoy.